So, again we are taking one problem related to the transportation. Here we are going to discuss the concept related to the degeneracy in the transportation problem. We are going to discuss the degeneracy concept in the transportation problem. Degeneracy. What is degeneracy? Look at the problem. This is the problem which is given to you. Here there is a 4 by 4 matrix. Here there is a 4 by 4 matrix. 4 by 4 matrix. There are four origins. There are four origins: O1, O2, O3, O4. There are four destinations. There are four destinations: D1, D2, D3, D4. And this is the availability. This is the availability. And here it is the requirement. Here it is the requirement. Look at here, this origin is given. This is the cost component. 1, 2, 1, 4. This is given. 1, 2, 1, 4. This is 3, 3, 2, 1. 3, 3, 2, 1. This is 4, 2, 5, 9. Another thing is 5, 3, 6, 10. 5, 3, 6, 10. Now this is given. This is 20, availability, this is 40, this is 30, not 30, this is 20, this is 20. So if you count it here, this is 100. If you count it in here, this is 100. Clear? So availability is 100, requirement is 20 on destination D1, on destination D2, the requirement is 40, on destination 3, the requirement is 30, and here it is 10. Again, if you count, the requirement is 100. Once it is a balanced problem, you can do that. So what we are going to do here, we will solve it with the northwest corner rule. We know there are 5 rules, but here we will solve it with the northwest corner rule. You can use any of the rules. I am here using only northwest. Once applying northwest rule, then we will later on do the optimality test. We perform the optimality test. Here it is 20, 20. In northwest corner rule, this was the concept. North, west, east, north, south, east, west. Clear? So this is 20, 20. Here it is 40, this is 0, this is also 0. So this is also cancelled. Clear? Here it is, you put it here 20, but whichever is that, you are going to put that one, availability and requirement. And this row has been exhausted. Then here it is 10, this is 0 here it is 10, this has been exhausted, this is 10, this is 0, this is 0. More one, please note one thing, when row and column are going to exhaust simultaneously, you will get the concept of degeneracy in the transportation problem. This is happening twice, once is here, another one is here. Here the row and column are getting exhausted at the same place, at the same time. Means if it is happening like this one, you will always get the concept of the degeneracy in the transportation problem. And when we will be able to know, when we are going to apply the optimality test. In optimality test, we are dealing with the MODI method, that is the modified distribution method, that is also known as the UV method. And here we will calculate the total cost. Look at the total cost. The total cost is, look at the total cost. This is 1 into 20 plus 3 into 40 plus 5 into 20 plus 6 into 10 plus 10 into 10. So this is the cost which you are getting. This is 20 here, this is 120, this is 100, this is 60, this is also 100. This is 140, this is 140, 100, this is 160. 0, 10, this is 400. This is the total cost for the movement from the place origin O1, O2, O3, O4 to the destination D1, D2, D3, D4. If these are the costs associated, you are going to spend total 400 rupees. It could be not, it could be a mostly it could be a dollar out, whatever the value you have been given. Now whether this solution is the optimal one, or that we need to perform the optimality test. Look at the optimality test. When you are going to perform the optimality test, there are two conditions which has to be satisfied, especially in the modified distribution method. We are going to discuss the MODI method. This is also known as the UV method. Clear? Now, what are the two conditions? Number one, all allocation must be independent condition. This gives you the it is an independent condition. All allocation must be independent condition. This is the condition number one, independent condition. The second condition is your actual number. What is actual? Count it 1, 2, 3, 4, 5. Your actual is 5. Actual number of allocation is 5. And what is the requirement? What is the requirement? Actual number is equal to 5. Required is m plus n minus 1. The number of rows are 4. Number of columns are 4 minus 1. This is 4 plus 4, 8 minus 1. This is 7. 5 can't be equal to 7. So this is the concept of degeneration in a transformation. How to address it? First of all, make a cost matrix or compress it. Please make a cost matrix for allocated cells. Please make a cost matrix for allocated cells. When you are going to make a cost matrix for the allocated cells 1, 3, 5, 6, and look at here. Now we are left with two more allocation. 1, 2, 3, 4, 5. There are 5, but we require 7. For getting the 7, we take the least value. The least value is there. If I put upside here, basically upside carries it is equal to 0. But for solving it, we are putting it. If I put it there, this is cost component is 1. Whether we are getting any new, we are not getting any new. Similarly, another least component, this is 1. Again, if I put upside here, if we are putting again here, again, we are here, there is no loop. Even if we get trapped here, we will not be proceed further. That I will explain later on if it is required. So, you will start with the least cost by giving the value of psi. What is the value of psi? Psi carries value 0. Psi is equal to 0. But it is going to assist in solving the problem basically for performing the optimality test. Now let us go to this is the cost matrix for allocated cells. This is the part 1, first step of the optimality test, cost matrix for the allocated cells. Then make a UI matrix. This is U1, U2, U3, U4. Then VI, V2, V3, V4. Now UI matrix for allocated. If I put a 0 here, get 1 here. 0 plus 1 is 1. Because if we add both these, it means U1 plus V1 is equal to 1. And here I have put the value of V1 is 0, then we will get V1. V1 is equal to 1. That is why V1 is 1. Once we get V1 here, 1 plus 0 is 1. 0 plus 5 is 5. 0 plus 6 is 6. 6 plus 4 is 10. 4 minus 3 is plus 1. If you are able to get that 3, here it is. If I put a value 6 here, 6 minus 2 is equal to 3. If you are able to get all this UI values, means there is no all allocation are in independent. If you fail to get these values, U1 to U4 and V1 to V4, means there is a dependency which exists. We need to address first of all. Go to the another step. Go to the another step. Another step was, if you recall, we have already explained this voting method. This is the second time we are explaining. So here we are going to address the degeneracy concept. Now make a cost matrix for non-allocated cells. Again, make a matrix. Again, make a matrix. This is here there is a allocation. We put a hyphen here. And if you add it 1 plus 6, this is 7. If you add 1 plus 4, this is 5. This is minus 3. 3 minus 3 plus 0, minus 3. Again this is minus 3. This is 5 here. 5 plus 0 is 5. 5 plus 6 is 11. 5 plus 4 is 9. Then 6 plus 0 is 6. Then 6 plus 6 is 12. This is called UI Vj matrix for UI plus Vj matrix for non-allocated set. For non-allocated set. Now let us proceed further. Now we are going to calculate the cell evaluation matrix. We are going to calculate the cell evaluation matrix. Look at here. Put a hyphen where the allocation has been made. These are samples in number 1, 2, 3, 4, 5, 6, 7. Now this has to be subtracted. Here it is 2, 2 minus 7. 2 minus 7. Clear? Then 4 minus 5. 4 minus 5. Clear? This is 3 minus minus plus. 3 minus minus plus. This is, here it is 2 minus minus plus. Clear? This is called cell evaluation. This is 4 minus 5. 4 minus 5. Clear? Then 2 minus 11. 2 minus 11. Then 9 minus 9. 9 minus 9. Now here it is 5 minus 6. 5 minus 6. Then here it is 3 minus 12. 3 minus 12. Look at here. I shall make a bigger one. Why? Because here we are going to make an iteration one. Now I am making a bigger one so that we have more clarity. I am making a bigger size. This is basically a 4 by 4 matrix. Look at here. You get a value here. This is hyphen. This is hyphen here. This is hyphen. This is hyphen. Clear? This is minus 5. This is minus 1. This is 6. This is 5. This is minus 1. Minus 9. 0. Minus 1. Minus 9. And here, there are so many cells in a cell evaluation matrix which are negative. So, this the solution obtained is not the optimal one. This is not optimal solution. 400. So, look at here. Out of that one, choose the most negative value. This is the most negative value, minus 9. When we are looking at the minus 9, if I choose this one, here there is the elevation, here there is the elevation, here there is the elevation. Look at it. So, in 3 corners, we are having elevation here, here. So, give a sign here positive. This is negative, alternative. Start with the positive one, then negative, then positive, then negative. When you are looking at a negative, there is a cell which is associated. This is the negative, minus 10, this is 40. 10 and 40, which is the allocation which is made here. So choose the least one. The 10 will be here. Here there is a 0, this is 10 here. Here it is 0, 10 minus 10 is 0. I put a cross here. 5 minus 10 is 0. So I put a cross here. Here, there is a phi. There is a phi. Phi plus 10 is 10. Because we are going to add it here. Here it is minus. Here it is minus. Here it is a 40. 40 minus 10 is 30. Rest of the things you are going to put it as it is. This is 20 here. There is no change. This is 20 here. This is a phi. This is a phi. And here is what is the value? This is given to here. This is 20. This is 20. And here is what is the value? This is 10. And if you count it here, look at here, this is 20. This is 40. This is 20. This is also 20. This was the original values 20, 40, 20, 20. So means whatever we are doing so far is perfectly okay. This is the availability. Similarly, look at the requirement. This is 20 here. This is 40 here. This is 30 here. This is 10 here. If you look at the requirement part, this was 20. For D1, for D2, this is 40. For D3, this is 30. For D4, this is 10. So again, calculate total cost. Now calculate the total cost. When you are calculating the total cost, the cost is 1 into 20. Here there is a 1 into 20 plus the upside 1 into upside this will be 0. Why? Because we are considering psi to be 0. We are just making use of for removing the degeneracy cost. Then here it is 3 into 30. 3 into 30 plus here it is 1 into 10 plus here it is 5 into 20 plus 3 into 10. Here it is 3 into 10 plus 6 into 10. If you look at here, this is 20, this is 0, this is 90, plus this is 10, this is 100, 30, 60. If you count it here, this is 100 times 120, 220, 250, plus 6, this is 300. Again check it. This is 100, 200, 290 plus this is 300. Earlier the cost was 400, now we are able to reduce by 90 rupees meal or $90. This becomes 300. Now whether this solution is the optimal one, again we are going to perform the optimity. Look at the optimity. I am going to rub it. This is the one again we are going to. I do require only these two metrics. This original one and the latest one. Again we are going to perform the optimity. Until and unless we get all the cells to be positive. Now, so this time I make a little bit smaller one. When actually I have a bigger one, we will make that one also. So again make up cross matrix for allocated cells. Now before that, again look at there are two conditions which have to be satisfied. Allocation must be visible. Actual should be required. Actually there is 7. 1, 2, 3, 4, 5, 6, 7. And required is also 7 because there is a formula m plus 1 minus 1. This will be 7, 7. Because 4 plus 4 minus 1. What is the number of rows? Number of rows are 4, number of columns are 4. So this is 7 is equal to 7. So we can perform with the optimalities. Let us proceed with the optimalities. Take the cost matrix for alphabetical 1. Again 1. This is here it is 3. Here it is 1. Here it is 5. Here it is 3. Here it is 6. This is the cost matrix for alphabetical. Now let us go to UIVJ matrix. Now UIVJ matrix is U1, U1, U2, U3, U4, V1, V2, V3, V4. Again give us 0 anywhere. If I give a 0 here, this has been explained in the previous step. This is 1 plus 0. Again 0 here. Here it is 5. Here it is 6. Clear? So here it is minus 3. And here it is 6. Here it is minus 4. Is it okay so far? Now we proceed further. Again make a cost matrix one.
तो पहले लाला साहब को तो अपना एफएम ले चो
Again make a
इधर
look at here. Again UIVJ matrix one non-allocated. UIVJ matrix one non-allocated. Look at here. For that, what we have, this is minus 2, this added, this is minus 4, clear? Minus 2, minus 4, UIVJ matrix for non-allocated. allocated cell. Here it is 6. Here it is 6. Here it is 6. Clear? And here it is 5. Here it is 2. Here it is 0. Here it is 6. Here it is 1. Now make a cell evaluation matrix. Again, make a bigger one little bit for the clarity purpose, because if we get any of the values to be negative, then again we have to perform the optimal matrix. 1, 2, 3. 1, 2, 3. I put a hyphen here because the allocation has already been made here. Okay. Now this has to be separated. 2 plus 2 is 4. This is 4 minus 4 is 8. Because 2, 4 plus minus. This is 3. This is minus 6 minus 3. 2 minus 6 is minus 4. This is 4 minus 5 is minus 1. 2 minus 2 is 0. 9 minus 0 is 9. 5 minus 6 is minus 1. Again, 10 minus 1 is 9. Again, so far we are not able to reach the optimal solution. Here, minus 4 is the most negative one. Now look at here. Look at here. Again, there is no allocation. This is plus. Here is the allocation. Plus, minus. And if I choose this minus is, look at here. This is 30 here, this is 10 here. Choose the least one. Choose the least one. Here it is 10. Because here there is no allocation, this is 10. Here it is 20. 30 minus 10 is 20. Here it is 10 plus 10 is 20. Clear? Here it is 10 minus 10 0. So put a cross here means there is 0 allocation. Now, here it is upside the rest of the value remains same. Here it is 20. Here it is 10. Clear? Here it is 20. So please look at here. This is 20. This is 40. This is 20. This is 20. This is the availability. Requirement is 20. Look at here. This is 40. If you add it 20 plus 20, 40. This is 10 plus 20, 30. Now phyla is 0. This is 10 here. Again, 100. Now calculate the EC. Again, I am going to getting the total cost. EC. What is here? Here it is. 1 into 20 plus 1 into phyla plus here it is 3 into here it is 3 into 20 clear plus 2 into 10 plus 1 into 10 1 into 10 plus here it is 5 into 20 5 into 20 plus 3 into 20. If you calculate the total cost here, this is 20, this is 0, this is 60, this is 20, plus 10, plus 100, plus 60. What is the value here? 20 plus 60, 80, 100, 110, 210, plus 60. This is 270. Again we got 310, now we are able to get 270. Means we are able to reduce by another 40 rupees on $40. Now whether this solution is the optimal one, again we are going to perform the optimal. Again we are going to perform the till the when we are going to perform the optimal till we get all the cells to be positive. So again we are going to perform the optimal. Look at the optimal. This time what I do is make a cost matrix for allocated cell. We do it in a hurried way also little bit. So this step has already been explained couple of times. So look at here, make a cost matrix for allocated cell. Again, prior to that one, two conditions has to be satisfied. What are the two conditions? The number should be 7, 1, 2, 3, 4, 5, 6, 7. This is the 7. And your all must be independent. This we assume it is already independent. If it is not independent, we are not able to solve this problem. This one is here, one is here, again one. Here it is 3, 2, 1. So far is it okay? Here it is 5, and here it is 3. Is it okay so far? This is 1, 2, 3, 4, 5, 6, 7. So let us make UI Vj matrix. You know UI. This is Vj. This is U1, U2, U3, U4. It has been explained a couple of times earlier. So we'll take 0 here, 1 here. Here it is 0. Here it is 2. Here it is 5. Clear? Here it is 2, here it is 1, 2 plus 1 is 3, here it is 2, here it is minus 1, because 1 is here. Here it is 1, here it is 3, here it is 2. 2 plus 1 is 3. So we can proceed further to make a cost matrix for non-allocated cell. Make a cost matrix for non-allocated cell. Let us do it. This has been put as a hyphen. So 1 plus 1 is 2, 1 plus 1 is 2, 1 minus 1 is 0, here it is 2, here it is 5, clear? Here it is 6, 5 plus 1 is 6, here it is 4, here it is 2, here it is again 2, here it is 1. Now let us make a cell evaluation matrix. This is the important matrix which decide. Again make a bigger one. If we don't get all the cells to be positive, again we have to perform the same optimality test. Maybe because we started with the northwest. In northwest, there is a probability of getting the optimality test is not at the earliest one. Maybe we need to perform the optimality test again. So if I put a hyphen here, look at here. Look at here. This has to be separated from the original one. 2 minus 2 is 0. 4 minus 0 is, this is 3 minus 2, it is 1. Now here it is problem, minus 1, 4 minus, again, there is a 2 minus 6, this is minus 1. 9 minus 2, this is 5. Then 5 minus 2, this is 3. Again, 6 minus 2, this is 4. Then 10 minus 1, this is 9. Again, we don't get the optimal value. Look at here, there are 2 cells which are negative. Let us maybe this time we will again. This is positive here, this is negative here, this is positive. We are going to use the iteration. This is the iteration. When we are doing it, this is 20, this is 20. Here, we are getting the degeneracy in between. Now, what happened here? We will get a 20 here, we get a 20 here. Clear? This is 20 minus 20, this is 0. This is 10 minus 20, this is 30. This is 0. Now we are getting the degeneracy in between the solution. This becomes a little bit complex problem. Again, we have to solve that one. So here is, we will leave actually rest of the one. This is 20 here. This is the phyla. And here it is 10. Here it is 10. What is the value here? This is the value which has already been mentioned. This is 20 here. Now look at here, this is 20, 20 plus 20, this is 40, this is 20, this is 20. Availability is this 20, 40, 20, 20. Now what is here? This is 20 here, this is the constant 20, this is 40, clear? 20 plus 20, 40, this is 30, this is 10. Now again this is 100 is equal to 1. Let us calculate the total cost. Easy. When we are calculating the total cost, 1 into 20 plus 1 into phyla plus 2 into 30 plus 1 into 10, clear? Plus 20 plus here 3 into 20. Now here, this is the value. 20 plus a phyla is 0 plus 1, 2, 3, 4, 5, 6. This is 20, 0 plus 60 plus 10 plus 40 plus 60. What is the value? This is 80, 90 plus 40. 90 plus 40, 130 plus 90. This is 190. We are able to reduce from 270 to 190. Is it okay so far? So this is now again. Now there is one column. If you look at here, there is one column related to that one. And when you want to perform the optimality test, you can't perform the optimality test. Why? I'm going to explain that right now. Look at this. Look at this. What is the reason? The reason is we get a degeneration in between the solution. So we are going to solve that one here. Look at here. So we are going to degeneration in our transportation column in between the files. Look at here. Now here, make a cost matrix for allocated cell. Make a cost matrix for allocated cell. 1, 2, 3. This is 4 by 4 matrix. Make a cost matrix for allocated cell. This is 1 here. Here it is 1. I am going to explain one concept immediately after writing this one. This 2 here is a make cost matrix. And here, if you count it here, 1, 2, 3, 4, 5, 6. If you count it here, 1, 2, 3, 4, 5, 6. Look at here. Now this is the degeneration because the number of this the actually 6, we require 7. So for that what we have to do 1, 1, 1. Here it is. If I do the allocation, here it is 10. Then all 1 has been made in the allocation. Go to the 2. In 2, if I do the allocation here, if I do the allocation here, if I choose this 1, there is no dependency. There is no dependency. Means this is the part which is here we are giving the value of phi here. This is the phi. In a later stage, basically we are giving the phi here. We are giving the phi. Are you getting what so far? Now again, we are UI matrix. Probably in this step we will get the answer U3, U4, V1, V2, V3, V4. If I get 0 here, this is 1 here, 1 plus 1, 2, 1 plus 0. Then 0 plus 2 is 2, 2 minus 1. Clear? Then here is 1 plus 1, 2, 1 plus 2 is 3. So we are able to get the UI matrix for allocation. Now proceed further. Let us assume I give it here. I am going to make a UI matrix for non-allocated cell. Let us make. Then after that we are going to make a cell allocation matrix. So that will decide now whether our solution is obtained or not. There is a probability to get the answer this time because not only that, so 270 to 180. We are able to reduce by another 30 plus 10. This is 70 plus 10, 80 rupees or $80. Now here it is. This is 0 here. Here it is 2. Here it is 3. Here it is 1. 1 plus 0. Here it is 1. Here it is 0. Here it is 2. Here it is 2. Here it is 1. This is called UI matrix for non-allocated cell. UI plus VJ matrix for non-allocated cell. Non-allocated cell. So we are going to calculate the cell evaluation matrix. This is the last step.
Let's go.
Which decide whether the solution has been obtained or not. This is the one. Look at here. This has to be subtracted from the original one. 4 minus 0 is 4. 3 minus 2 is 1. There is 3 minus 3. This is 0. This is 4 minus 1. This is 3. 5 minus 1. This is 4. 9 minus 0 is 9. 5 minus 2. It is 3. 6 minus 2. This is 4. 10 minus 1. 9. If you look at here, all the cells are either 0 or positive. Once this has been achieved, means the solution obtained is optimal. What is the optimal solution? This is the optimal solution. And what is the allocation? The allocation, this is the final allocation. We started with the 400 that we reached by 190. This is the saving which we have here. We saved rupees 210 or rupees $210. And I put it here 1, 2, 1, 4, 3, 3, 2, 1, 4, 2, 5, 9.